All right, let's get through this review here. I'll try to go quickly but thoroughly. That way you can get through the whole thing and not have to worry about it. Of course, my phone is ringing right now. Okay, so our number one, let's start with number one. Remember, our key is to factor. So if we're factoring this number one, I can take out a 3x. And what's left is an x minus 5. On the bottom, we can take out an x, and we have an x plus 3. I can't cancel these, but I can cancel the x's here. So we have a 3 and x minus 5 over x plus 3, and that is your final answer for number one. Now remember, domain is set the original, the OG denominator not equal to 0, right? So it's the very first one, x squared plus 3x not equal to 0. So we have x and x plus 3 does not equal 0. You have to separate them. And then x plus 3. And then solve. So we're going to subtract 3. So one of your domain features is x cannot equal 0. The other one is x cannot equal -3. So make sure you put both on those. All right, number 2, can't factor anything on the top. Well, we can factor out a 16x on the bottom. We'll just start over. 16x, and we have x minus 1. What can I cancel? I can reduce my 8 and 16. 8 goes into 8 one time. 8 goes into 16 two times. Then I have 3 x's, 1 x I can subtract, and so I have 2 left on the top. So my final answer is x squared over x minus 1. I cannot cancel those because they're being subtracted on the bottom. All right, original denominator, set not equal, that's just a 1, not equal to 0. Factor, x minus 1, 16x does not equal 0, x minus 1 does not equal 0, x does not equal 0, and x does not equal +1 because you got to add it there. Okay, you can always look on your calculator to see if you have any holes or those undefines, because when you select -3, you would have an undefined value for y. All right, next, number 3. Let's factor the numerator. So we have x minus 2 and x plus 2. On the bottom, what multiplies to get 16 adds to get 10. I'm going to say 8 and 2. So I can cancel this x plus 2, and we have x minus 2 over x plus 8. And then our domain, I'm just going to already factored form, does not equal 0. So x cannot equal -8 and -2. So 2 answers there. Next one, let's factor out an x. So we have x plus 7 over 2x squared. We can take one from the top and one from the bottom. So we have x plus 7 in the numerator and 2x in the denominator. So original 2x squared does not equal 0. Divide by 2. X squared does not equal 0. Square root, and x does not equal 0. So just 1 on that one. All right, number 5. Let's factor. We can factor out a 4x on the top. So we have x minus 5. This is difference of 2 squares. So we have x minus 9 and x plus 9. Really? That's kind of dumb. That's your answer. You can't simplify that any further. All right. Well, there it is. Just checking my notes to make sure. All right, so I'm going to do x minus 9. X plus 9 cannot equal 0. X minus 9 cannot equal 0. X plus 9 cannot equal 0. So x cannot equal 9 and -9. So 2 domain restrictions there. Whoops, you couldn't see that. All right, number 6. Let's factor out a 9 here. So we have x plus 8. What multiplies to get 16 adds to get 10 is x plus 8 and x plus 2. And then on the other one is multiplies to get 18, adds to get -7. I'm going to say -9, +2. And then we just have an x minus 9. All right, so when you're multiplying, remember that anything on the top can cancel with anything on the bottom. So you can cancel here and across. So we can cross cancel here. We can simplify here. We can simplify here. That's nice. Everything. So what's left on the top is a 9. Left on the bottom is a 1. And 9 over 1 is 9. All right, so our domain, think its original denominator. So it's x plus 8, x plus 2, and x minus 9 cannot equal 0. Okay, so keep that in mind. Even when you're doing operations here, it's the original denominator. So x cannot be -8, -2, and 9. For these, you do not have to do the infinity with the parentheses. I'm fine if you just do the x cannot equal, okay? That does the trick too. All right, number 7, we're dividing. So I'm going to flip it first. So we have 7x cubed over x squared plus x minus 30. And we're going to multiply by the reciprocal. So I have x squared minus 36 over x squared minus 6x. That's a funny minus there, but I'm pretty sure it's a minus. So we have 7x cubed over what multiplies to get -30 and adds to get 1. That's going to be a +6 and a -5. Here is a difference of 2 squares. So we have x minus 6, x plus 6. And then we can take out an x here and have x minus 6. So now that we're multiplying, anything on the bottom can cancel with anything on the top. So I can cancel x and 6, x plus 6, cancel the x here with one of the x's here. So we have a 2 left. So let's see, on the top, we have a 7x. On the bottom, we just have that x minus 5. All right, so original denominator, and that's this one, because when you're dividing, you're actually multiplying by the reciprocal. So we're taking this one down here. X plus 6, x minus 5, x, and x minus 6 cannot equal 0. So all of these things are separate. X plus 6 cannot equal 0. X minus 5 cannot equal 0. Running out of room. X cannot equal 0, and x minus 6 cannot equal 0. So if you solve this one, x cannot equal -6. Solve this one by adding 5. X cannot equal 5. This is 0, and this one is +6 is 6. So 4 domain restrictions there. All right, last one here. Let's factor. So we have x squared. We can pull out an x squared. That leaves us with x plus 8. The denominator, what multiplies to get -56 and adds to get 1, that's going to be +8, -7 times, let's see, multiplies to get 28, adds to get 11. I think -11, I think that's -4 and -7. And then we have 4x down here. All right. Anything on the top can cancel with anything on the bottom. So we can cancel the x plus 8, x minus 7. One of the x's down here can cancel with one of the x's up there. What's on top? We have x times x minus 4. And on bottom, we just have a 4. It's nice. All right. So our domain is the original denominator. I'm going to take the factored one. Is x plus 8. X minus 7, and this 4x cannot equal 0. So we have x plus 8 cannot equal 0, x minus 7 cannot equal 0, 4x cannot equal 0. Subtract your 8, x cannot equal -8, add 7, cannot equal 7, divide by 4, and cannot equal 0. So 3 domain restrictions there. All right, number 9. Well, this is a doozy. All right, so we're going to multiply and divide. So what I'm going to do is I'm going to factor. So here I'm going to factor out a 2 and an x squared. So we have x squared minus 25. Oh, we can factor even further, can't we? So this becomes 2x minus 5 and x plus 5. I don't have a whole lot of room. This one here, what multiplies to get 30 adds to get 11. x plus 5, x plus 6. And then we have an x minus 10. I'm going to cross this out so we don't get confused in a second. And here I'm going to go ahead and multiply it. I'm going to skip a step here. I think you'll be okay. This denominator is now my numerator, but I'm going to factor it at the same time. So I can pull out a 4x and it becomes an x squared minus 100, which can be factored even further to x minus 10 and x plus 10. Jeez. Totally running out of room. All right, so what multiplies to get 60 and adds to get 16, 10, and 6. I'm going to cross this out so we don't see it anymore, so we don't get confused. Okay, now that we're multiplying, this is good. It's just whatever's on the top can cancel with whatever's on the bottom if it matches. So I see x minus 10, x minus 10, x plus 10, x plus 10, positive 5 plus 5, x plus 6, x plus 6, and then the 4 and the 2, so that becomes a 2. So let's see what I have on the top. I have a 6, a 2, and an x. So I have a 12x on the top. On the bottom, I have an x minus 5. That looks pretty good. Let me check my little answer key here. Make sure I'm looking good. Yep, looks good. Okay. So domain is original denominator. So I'm going to take all of these things that are factored down below. 2x minus 5, x plus 5, x minus 10, x plus 10, x plus 6 cannot equal 0. Jeez Louise. Okay, this 2 and 0, that one doesn't count. I'm going to add 5 here, so x cannot equal 5. Subtract 5 there, we get x cannot equal negative 5. Add 10, negative 10. I'm just switching the signs now, and I think that's it. Ooh, I wonder what this looks like on a graph. I'd be interested to see that. All those domain restrictions. Okay, kind of the same thing here, except we don't have to flip anything. We're just factoring all the way. So we're going to keep that x minus 10. And we have what multiplies to get negative 7 or 70 adds to get negative 17. X minus 7, x minus 10. All right, what multiplies to get 63 adds to get 16, 7, and 9. Minus 9 on the bottom. And we have a 3x here. Okay, so let's see what matches. I'll put these in parentheses so we can keep them together. All right, x minus 10, x minus 10, x minus 9, x minus 9, 7, 7. That's great. And we can reduce these. 3 goes into 3 one time. 3 goes into 6 twice. So we get a 2 on the top, x on the bottom. Beautiful. All right, domain is all of this. So x minus 7, x minus 10, x minus 9, and 3x cannot equal 0. So x minus 7 cannot equal 0, x minus 10 cannot equal 0, x minus 9 cannot equal 0, 3x cannot equal 0. I just didn't do that on this one because I didn't have any room. It's probably not a very good excuse, is it? All right, so x cannot equal 7, add 10. X cannot equal 10, add 9. X cannot equal 9, divide by 3. And x cannot equal 0. All right. It's a lot of domain restrictions. Done with domain restrictions. Now we get just do the operations. We did these in class together. However, let's keep going. Should I use our highlighters? Maybe. Maybe we shall. Okay. So I'm going to highlight my common denominator. I can't factor these, but I'm going to highlight my different denominators. I don't have any matching colors, so they just get mushed together. So my common denominator is x plus 3 and x minus 2. My first guy needs an x minus 2. And my second guy needs an x plus 3. All right, so I'm going to distribute this x. So we have x squared minus 2x. Then we're going to distribute this 5, except keep in mind that it's a negative 5. So we're going to distribute a negative 5. So we have negative 5x minus 15. Now we'll combine our like terms here. So we have x squared minus 7x minus 15 divided by x plus 3 and x minus 2. And that's your answer there. Good. All right, next one, you can highlight. Notice they're not the same. So my common denominator is going to be x minus 4 and x plus 8. So this guy needs an x plus 8. This guy needs an x minus 4. So this one we're foiling, right? So first, outside, inside, last. So first, outside, inside, last. 2x squared plus 16x plus 3x plus 24, right? Then we're going to distribute our positive 3 to plus 3x minus 12. Now we'll combine our like terms. So we have 2x squared, that's 19. So 16 plus 3 is 19. 19 plus 3 is 22. And then 24 minus 12 is 12. All over x minus 4, x plus 8. All right, looking good. Halfway done. You can do it. Next one is this one. So I'm going to factor first. This is my first one that I can factor. It's x minus 1 and x plus 1. So I'm going to look, I'm going to kind of use my marker, my highlighters here. Those are pink. And here's a purple one. So it looks like my first guy needs the purple one, which is x minus 1. So I need to multiply this one by x minus 1. So we'll distribute the 7x. And our common denominator is x minus 1, x plus 1. Both the colors together, combined. So we have 7x squared minus 7x. This guy didn't need anything because he already had both. So we'll just say plus 7. You can factor out a 7 here. You don't have to because it doesn't really get you anything, but just to follow all of our steps, and that's your answer. No canceling on that one. Bummer. All right, factor first. So we'll factor here and we get x minus 5 and x plus 3. So my common denominator is x minus 5, x plus 3. This guy needs an x plus 3. My first term doesn't need anything, so we just bring it down, x plus 5. Here we're going to distribute the -1. Keep in mind that if there's a negative here, you're going to bring that with the number. So it's negative x minus 3. And then let's combine our like terms. So our x's cancel out, don't they? And then 5 minus 3 is 2. So we have x minus 5 and x plus 3 as the denominator. All right, good job. Let's keep going. This one's kind of crazy, but we'll make it. Some of you did this one in class. We have x plus 4, x plus 3. This one is a difference of two squares, x minus 3, x plus 3. And then x minus 4, x plus 4. Difference of two squares for both of those. So my common denominator is all of it. X plus 4, x plus 3, x minus 3, and x minus 4. So I'm going to determine, it's going to get a little bit long, lengthy. I'm going to determine what each term is lacking from the original. So this first term has x plus 4 and x plus 3. It's missing x minus 3, x minus 4. Okay. The second one, it has x minus 3 and x plus 3. It's missing x plus 4, x minus 4. All right, my last one has x minus 4, x plus 4. It's missing the x plus 3, x minus 3. All right, so in order to get these, it's all multiplied by 1. So FOIL first, and then distribute the 1, even though that doesn't really change anything. So we're going to FOIL, first outside, inside, last, first outside, inside, last. So we have x squared, give myself some room, minus 4x minus 3x plus 12. Now we're going to do this one. First, outside, inside, last, plus x squared minus 4x plus 4x minus 16. Last one, first, outside, inside, last, x squared minus 3x plus 3x minus 9. All right, combine our like terms. 1x squared, 2x squared, 3x squared. Now my x's, that's a negative, negative. Oh, these cancel, don't they? That's nice. So we have a negative 7x. And then my numbers here. 12 minus 16 is negative 4, goodness, minus 9 is negative 13. All over x plus 4, x plus 3, x minus 3, x minus 4. And that's your answer there. Let me just check. Let me check mine. There we go. Key. A little bit crazy on that one. Okay, the only one I can factor on this, on number 16, is that last one, x minus 1, x plus 1. Okay, so, but let's use this, because I want you to use it. If the colors help, I definitely want you to use them. And then we have this lonely little x here, still counts for our common denominator. So in our common denominator, we need all three colors. We need x minus 1, we need x plus 1, and we need x, okay? So let's see, what does 3 need? Or what does my first term need? It needs an x and it needs an x plus 1. My middle term needs both x minus 1, x plus 1. And my last term needs an x. All right, so we're going to call this 3x and distribute. So we have 3x squared plus 3x. FOIL and then multiply by 2. So we have, I'm going to work it out over here. X squared plus 1x minus 1x minus 1. So this is 2 times x squared minus 1. So we have, ooh, don't forget that's a negative 2. Most missed it. 2x squared plus 2. And then we have distribute our x here plus x squared plus 3x. Okay, combine like terms. Here we go. All right, so 3 minus 2 is 1. 1 plus 1, 2x squared. All right, then we have our x's, 3 plus 3, 6x. We have our 2 on the end. And our common denominator, x minus 1, x plus 1, and x. Okay. Let's factor. So we have x, let's see what multiplies to get 50, 10, and 5. X plus 5. Here we can factor out a 2. We can factor out a 2 here as well. Okay, so colors, if they help, let's use them. We have an x plus 10 there. That's great. We have some matching things. 5 and 5, and 2 and 2. So we need all the colors in our common denominator. We need 2, we need an x plus 10, and we need an x plus 5. So what are we missing? This guy's just missing a 2. This one's missing an x plus 5. This one's missing an x plus 10. All right, so let's multiply. We've got multiply 2x, distribute our 7. So we have 7x plus 35. Distribute our negative 3. Keep in mind that's a negative. So we have negative 3x minus 30. All right, combine our like terms. 2x, 7x is 9. 9 minus 3 is 6x. And then 35 minus 30 is 5. So we have 2, x plus 10, x plus 5. That's your answer. Can't do anything else, even though I really want to cancel out that x plus 5, but it's attached to that 6, so we can't do anything. All right, keep going. Number 18. Best thing I can tell you to do is write this horizontally. That means divide. It's just a multi-step, so it's going to be like doing it multiple times. So we have x minus 3 over 2 plus 1 over x divided by 1 over x minus 1 over x squared. So I need common denominator here. It's 2x. This guy needs an x. This guy needs a 2. So distribute our x here. we have x squared minus 3x plus 2. And this is divided by, all we need is an x over here, because our common denominator is x squared. So we have an x minus 1. All right, we're going to combine our, oh, we don't have any like terms there. They're all different. Our next step is if we're dividing fractions, we're going to flip and multiply, right? So we have x squared minus 3x plus 2 over 2x times x squared over x minus 1. I know I can factor this. What multiplies to get positive 2 and adds to get negative 3? I'm going to say minus 2 minus 1. All right, so, oh, that's nice. Those cancel. I can cancel 1x down here with 1x up there, and there's 1 left. So let's see what's up top. X and x minus 2. And on the bottom, we have a 2. That's your answer. All right, 2 more like this. Let's write them horizontally. So we have x plus 4 over 3 plus 1 over x divided by 1. I'm going to change that to a fraction by placing it over 1. Remember, you can change it any whole number into a fraction by placing it over 1, and then 1 over x. Common denominator here is 3x. This guy needs an x. This guy needs a 3. So distribute x squared plus 4x, and then we have 3 times 1 is 3. All right, common denominator here is x. This guy needs an x. So we have x plus 1. Okay, dividing fractions, flip and multiply the second one. So we have x squared plus 4x plus 3 divided by 3x times x over x plus 1. All right, I'm pretty sure I can factor this. What multiplies to get 3 adds to get 4, 3 and 1. Cancel our x plus 1s there. I cancel the x here with this one. So we have x plus 3 over 3. We cannot cancel the 3's because it's being added on the top, only if they're being multiplied. All right, last one like this. You can do it. Feeling my energy wane, but that's okay. We're going to make it through. All right, x squared divided by 9. I'm going to put this 1 over 1. Write it horizontally by dividing there. So we have x minus 6 over 9 plus 1 over x. All right, common denominator here is 9. This one needs a 9, doesn't it? All right, so we got x squared minus 9 here, divided by, common denominator is 9x. This guy needs an x. This guy needs a 9. So distribute our x, we have x squared minus 6x plus, and then we have a 9 here. All right, let's flip and multiply. This is x squared minus 9 over 9 times 9x divided by x squared minus 6x plus 9. All right, let's see if we can factor. This is a difference of 2 squares. I immediately see that. So we know it's x minus 3x plus 3. This one, what multiplies to get 9 adds to get 6. Negative 3 and negative 3. So let's cancel. We can cancel the 9's here. That's good. All right, so let's see what we have on top. We have x plus 3 and an x, and we have x minus 3 on the bottom. All right, looks good. Hey, you're done with adding and subtracting. Woohoo. Let's move to the back. We're going to simplify. So remember, when you're dividing, you're subtracting your exponents. That might help us here. Your numbers, you can cancel just like we did in the simplifying. So 4 goes into 4 1 time and 4 goes into 8 2 times. So I have a 2 on the bottom, and we'll subtract your exponents. So 3 minus 7 is negative 4. That tells me that the 4 goes on the bottom. 7 minus 8 is negative 1. That tells me that the 1 goes on the bottom. And if there's nothing on the top, it's a 1. That's the answer. All right, 32. Let's reduce these by 2. So we have 5 and 2. I like to make my fraction first and then go forth. Subtract your exponent. 6 minus 7 is negative 1. Tells me it goes on the bottom. 7 minus 2 is positive 5. Tells me it goes on the top. The positive. If your exponent's positive, it goes on top. Negative goes on the bottom. All right, 5s and 5s cancel. So I have 1 minus 2 is -1, so x goes on the bottom. 1 minus 7 is negative. 1 minus 8 is -7. 7 goes on the bottom. If there's nothing on the top, you put a 1. All right, last one. You can cancel these. We get a 2 on the top. So I have -5 minus 6 is -11. Tells me it goes on the bottom. 3 minus 1 is 2. +2 tells me it goes on the top. And you're done. That's kind of a ninth grade review. All right, find the inverse. Find the inverse is switch x and y. Solve for y. All right, so we'll try this. So we have x equals y to the 5th minus 6. Solving for y, so we'll add 6 on both sides. We have x plus 6 equals y to the 5th. The opposite of raising something to the power is the square, or is the root of that power. So y equals the 5th root of x plus 6. All right, 36. Switch x equals 2 times the 4th root of y plus 4. So we're going to solve for y. I'm going to move 4 over first. X minus 4 equals 2 times the 4th root of y. Divide by 2. So we have, moving over here to give myself room, x minus 4 divided by 2 equals the 4th root of y. The opposite of the 4th root is raising it to the 4th power. So we have x minus 4 over 2 to the 4th power equals y. The end of that one. All right, 37. Switch x equals y to the 1/3 power minus 9. You can think of this y to the 1/3 power is the same as the cubed root of y. They mean the same thing, so you can write it either way. But let's add 9 first. So we have x plus 9 equals y to the 1/3, and the opposite of that is raising it to the 3rd power. So we have x plus 9 to the 3rd power equals y. And that's your answer there. All right, last one. This one takes the most amount of steps. Switch x equals 3 divided by y plus 7. We can only multiply by the denominator, so let's multiply by y plus 7. I'm going to use my algebra skills because this is x times y plus 7 equals 3. But I want to get my y alone, so I'm going to divide by x. So I have y plus 7. And that helps me get rid of those parentheses when I divide by that x. Subtract 7, and we have y equals 3 over x minus 7. It's all about manipulating, right? Manipulating that algebra. Okay, the next one. Here's how I want you to write this. We want to write it in a f of x minus h plus k. So we want to write it in a function notation, okay? So if we're starting at 1, 1, and we're going to -7, 1, let's talk about what you're doing. You're doing 1 to -7. That means that you're moving to the left 8. And then if you're going from 1 to -1, that means you're going down 2. So I want to put these values in for h and k. So we're going to say f of x and left. If I'm going left, I'm going toward negative, which means I'm adding 8, right? So it's opposite. And then down 2 is -2. So that will be your answer for that choice. I know some of you caught onto this one. Some of it was a little bit tricky when we did this on the last test. All right, 1, 1 to 10, -12. 1 to 10, you're going to the right 9. If it helps to write it helps me to visualize it by writing it out. If you want to draw it, you can do that. Okay, 1 to -12, you're going down 13. So the 9 goes in the H, the 13 goes in the K. If you're going right 9, it's opposite. You're going to subtract 9 and down 13. Okay. Whew. Hopefully this review helped, and you're going to do fine on your test. No worries. I'm not worried at all. And I will see you in class.